Although it may seem strange, space researchers look back in time every day using the James Webb Space Telescope. This year, thanks to the telescope's impressive images of the universe, has been one to remember. These images allow us to observe galaxies that existed in their pre-13 billion year state. It's the perfect time to appreciate the privilege of having a first-class seat on the cosmic elevator and the ability these photos give us to travel through time. The James Webb Space Telescope provides depictions of the early universe, star birth and death, galaxy mergers, and planetary atmospheres. Its scientific discoveries have been astonishing, breaking barriers and exceeding expectations. How did it enable us to observe the universe's very first galaxies? Which of its findings defy the laws of physics, and have we discovered any signs of extraterrestrial life? Join us as we explore the discoveries made by the James Webb Space Telescope, including the recent revelation of galaxies that defy modern physics. The speed of light is one of the most fundamental laws of physics that govern our universe. When we talk about light, we refer to all wavelengths of the electromagnetic spectrum that move at an incredible speed of 300,000 kilometers per second. Although light appears to be instantaneous in our daily lives, traveling anywhere in the galaxy still requires time, even at remarkable speeds. When gazing at the moon, you are actually observing it as it was 1.3 seconds ago. Though a mere glimpse into the past, it is still the past. The difference is that it takes photons, or light particles, over 8 minutes to travel from the sun's surface to Earth. This means that every time we look at the sun, we see it as it was 8 minutes ago. Our galaxy, the Milky Way, is an awe-inspiring expanse of stars, planets, and other celestial bodies that stretches more than 100,000 light-years across. The stunning young stars visible in the Carina Nebula image from the JWST are located 7,500 light-years away from us. In other words, the light that we see from the Carina Nebula began its journey towards us around 7,500 years ago. This was around the same time that human civilizations were first beginning to emerge in various parts of the world. To put it into perspective, the historical period represented by this nebula is around 2,000 years earlier than when ancient Mesopotamia developed the first form of writing. As astronomers look away from Earth and into the past, they utilize light observed across time to piece together the mystery of our universe. The Hubble Space Telescope used the ultraviolet, UV, and visible portions of the electromagnetic spectrum for its construction and optimization. However, these light spectrums are blocked by Earth's atmosphere, which is why space-based telescopes are crucial. The JWST, on the other hand, was designed to work with various infrared light, allowing it to delve further into the past than the Hubble. By observing infrared light, the JWST can see through dust clouds, which obstruct visible and UV light, providing a clearer picture of what lies beyond. Galaxies emit a variety of light wavelengths, including gamma rays and radio waves, in addition to the visible and infrared light that we can observe. By studying the light emitted by galaxies, astronomers can learn about their age, distance from Earth, and other crucial characteristics. By observing galaxies that existed billions of years ago, the JWST has the potential to unlock new insights into the formation and evolution of the universe. On July 12, the world was treated to some of the James Webb Space Telescope's first awe-inspiring images and data, as NASA's Near-Earth Object Wide Field Infrared Survey Explorer, NEOWISE, released them to the public. The telescope captured 4 targets, each of which consists of 3 photos and a spectrum, all of which beautifully capture the infrared world. The night before the release, President Joe Biden made a 4th image public during a live broadcast, showcasing a sharply focused ultra-deep field view of an older universe than anything we have seen before. These images and data provide an excellent glimpse of how the James Webb Space Telescope has evolved into a useful research instrument and highlight the telescope's great potential to advance science. The 3 photos in the Stephan's Quintet group of galaxies, the Southern Ring Nebula, and the Carina Nebula, along with the spectrum of WASP 96b, provide an exciting look into the universe. The Carina Nebula is one of the largest and brightest nebulae in the sky, located 7,600 light-years away from Earth. It contains Eta Carina, a fading supergiant star on the edge of a catastrophic explosion, as well as Trumper 14, one of the newest known star formation clusters, whose diameter exceeds 300 light-years. The Carina Nebula is a large and active stellar nursery, constantly buzzing with activity that is simply mesmerizing. The latest stunning image from the James Webb Space Telescope provides new details about the cosmic cliff of the Carina Nebula, allowing us to appreciate its grandeur like never before. What's more, the telescope's advanced technology now enables us to observe new stars for the first time that were previously completely hidden from view. The telescope also captured images of 5 galaxies known as Stephan's Quintet, located 290 million light-years away from Earth but seeming impossibly close to one another due to their interactions. 3 of the galaxies have evolved into lengthy spiral-like formations, while the other 2 are engaged in a type of cosmic dance that will eventually lead to the collision of the quartet. The 5 stars in the group range in age from very young to quite old, representing hundreds of millions of years of cosmic history. Not every significant picture captured by the James Webb Space Telescope will be visually pleasing. Some of them will be maps like the one NASA recently unveiled, which consists solely of lines, dots, and squiggles. The striking impact of Webb's view of galaxy clusters and the magnificent beauty of the Carina Nebula image are missing from that graph, but the tiny map is intriguing in its own quiet way, as are the numerous other charts that the Webb telescope will produce over the next 20 years. These photographs will push our capacity to imagine the characteristics of worlds that are far outside of our solar system. One of the targets, a large gaseous exoplanet that resembles Jupiter, is shown in the figure with extensive information on its atmosphere. WASP 96b travels around its Sun in approximately 3.5 days and is 1,150 light-years from Earth. The temperature inside it exceeds 1,000 degrees Fahrenheit, about 538 degrees Celsius, and it is the only known cloudless planet. WASP 96b has remained a mystery and a top area of interest for further study since its discovery in 2013. The James Webb Space Telescope has opened new avenues for exploring and understanding the vast and fascinating universe around us. Webb's new observations of exoplanet WASP 96b are providing scientists with valuable information about the atmosphere of this unusual planet. By examining the starlight reaching the planet's hemisphere, Webb has identified telltale signs of water and evidence of clouds. Unlike Earth, where water forms clouds, rock condenses in the air to form clouds on WASP 96b due to the intense heat. Webb's observations also indicate that many other substances besides water can condense under certain pressure and temperature conditions. The James Webb Space Telescope is expected to revolutionize our understanding of exoplanets and the potential for habitable worlds beyond our own. With an estimated 300 million potentially habitable planets in the Milky Way galaxy alone, these exoplanets will no longer be viewed as enigmatic cosmic objects, but rather as tangible locations with their own unique skies. The telescope will also allow us to explore the most distant corners of the universe, including galaxies that existed shortly after the Big Bang. Before the deployment of the JWST, the most distant confirmed galaxy was GNZ 11, which was observed by astronomers approximately 420 million years after the Big Bang, giving it a redshift of 11.6. Redshift is used to express how much the universe has stretched the light coming from a galaxy, with higher redshift values indicating a further distance from Earth. With the JWST, we will be able to observe galaxies as far back as 100 million years after the Big Bang, which took place 13.8 billion years ago. The James Webb Space Telescope, JWST, has revolutionized our understanding of the universe. Webb's new observations have provided scientists with more knowledge about unusual atmospheres, such as the exoplanet WASP 96b. When Webb examined the starlight reaching the exoplanet's hemisphere, it was able to spot the telltale sign of water and even evidence of sand clouds, despite the planet's incredibly high temperature. Webb's discoveries have made it obvious that many other substances besides water will condense under the right pressure and temperature conditions, which means that exoplanets will no longer be viewed as enigmatic cosmic objects, but rather as very real locations with an alien sky. Thanks to the Webb telescope, we now know that there are an estimated 300 million planets in the Milky Way galaxy alone that may be habitable, and several of these planets are located just 30 light-years from Earth, making them humanity's neighbors in the galaxy. However, the expanding cosmos has created a mismatch between the actual distance of galaxies and the amount of time it takes for their light to reach us. Light from 13.7 billion years ago is visible to us, but those galaxies are not 13.7 billion light-years away from us. Due to dark energy, which is believed to be a universal constant operating uniformly over all of space-time, the cosmos is actually about 93 billion light-years across, despite being only 13.8 billion years old. While we are unable to observe the impact of dark energy inside the Milky Way, we can do so across much longer cosmological distances. A week after the first JWST science photos were made public, astronomers announced the discovery of galaxies at redshift 13, or roughly 300 million years after the Big Bang. The record is currently being broken by a new wave of scientific discoveries, with some astronomers reporting the discovery of galaxies up to a redshift of 20. If this is the case, then we are witnessing these galaxies in their pre-Big Bang state, but this has not been verified yet. Spectroscopic study, which divides an object's light into a spectrum, will be needed to verify the distances of these galaxies. However, it is apparent that JWST is completely able to find galaxies from this long-gone age.